Welcome to the Robot Lab. Here, together with our students, teachers, our researchers, and our partners from practice, we are trying to implement our dream, a wood upcycling factory, where we can uptake leftover wood from the industry, make use of our robotic technologies, and help propel and accelerate the circular transition.
Currently, waste wood from the wood manufacturing industry is thrown away or burnt. Well, it doesn't make sense, because here in the Netherlands we have very little territory for forestry, which basically means that we have very limited local wood resources in the country. Meanwhile, all of this wood could be reused. For example, this piece of wood is in perfect shape for reuse. Even though it has some features from manufacturing, it's still good enough to make good use of it. So here at the Robot Lab, we are using waste wood from the manufacturing industry to turn it into valuable products, making use of digital design and the power of smart industry technologies.
On average, the hospitality sector renovates their interiors every 9 years, resulting in considerable waste. Which is why we investigated circular applications for the hospitality sector using computational design. We created prototypes of a wall paneling system using leftover materials from industry and multiple axis CNC milling. The robot mills out recesses, which then end up forming an interlocking geometry.
With our digital twin, we can simulate the actual production with our robots. And this helps us, even without having the robots running, to get data on production time, energy consumption. And with this data, we can evaluate the feasibility, the business case, we can optimize it, and we can also simulate parts of the production which we actually do not have yet here at the Robot Lab.
We helped the project by delivering software to the project, but we also provided in-kind assistance of people helping researchers to build innovative digital twins within the framework of the project.
For each of the designs we make, we calculate the business case, and we develop a model to evaluate the circular impact of each of the different designs and productions. Because in the end, we want to know if it's worth it.
I'm most excited about this project is to really make a pilot of the panels that we've designed together for they are lying here. And we've designed a project in Leeuwarden, and there's a wall, and we can make those panels on that wall, and it's in a restaurant, and it would be very nice if it's in half a year we have that project and we managed to do this together. So let's make them real on a wall.
Together with our partners, we decided to continue the project and build an entire wall. A digital wood database forms the basis for our design generator, which uses a set of different algorithms to fill in tile patterns based on the available material in the database. Through a back and forth process together with Timmerfabriek Visser, we managed to tweak the system to allow for direct file-to-factory production. First, the saw creates the outline for multiple pieces that are populated onto a single beam. Pieces are sorted and stacked according to a numbering system with a corresponding sticker. A manual and dry fitting are used to ensure that all the pieces fit together. Glue is applied to a backplate, which is then placed in a mold. The pre-assembled pieces can then be transferred onto the backplate. Together, we made 32 square meters of interior wall paneling, which was then shipped to Leeuwarden and installed by the local contractor, bringing a successful end to this project.